Hello again, and now let's make things a little bit more interesting by including an analog output. So, we will start with a situation with which we finish the last video tutorial, namely 3 different digital outputs for 3 different regions of values in the analog input. As I said before, this light sensor is gradually becoming a kind of a proximity sensor because the amount of light is directly related to how close is my hand on top of the LDR, so how close it is to the surface of the LDR. So in the previous one we made the RGB LED shine red if the hand was closest. Now I would like to make this red RGB LED blink when the hand gets to that limit, and from then on, as the hand gets closer and the light that gets into the LDR gets dimmer, I would like the LED to blink faster. If we attach in parallel a buzzer connected to the same points as the red terminal of the RGB LED, we'll get a sound alarm that will chirp with the same rhythm as the red LED blinks. So how can we accomplish this? Well, as we have been noticing before, the numbers from the analog input decreases when the hand gets closer and the light gets dimmer. We can use that numbers, that ever decreasing numbers, to be the ever decreasing interval between blinks and chirps. Well, so the part in which the red one is signed is this if statement. Now I got here a digital write red high. Now I want it to stay high and then to stay in a state of low, like this, and the time it is going to remain high and low will be directly related to the numbers in the sensor. So I'm going to use a weight in control like this, and another one for this, because as I told you before, if we go to the wiring code, we can see it is part of a loop and it's going to repeat. So depending on the value of the delay, it will repeat faster or slower. and if there's no delay, it will keep shining continuously because there's no time for it to be low if there's no delay in the low port, or it is going to be low always because there's no time for it to stay high if we miss the waiting for the high. So now we are going to start with the value of the variable here, the sensor variable, and we will have equal time on and off for the blinking and for the chirping. So with this simple variation, we have converted the right light into a blinking right light, and if we got the buzzer into a chirping in the same rhythm. Now it's the time to check how is this going to go. If you remember, we are going from values of 600 to values of 500 and something. So the change in timing, the speeding up of the blinking and chirping, is not going to show that much, because it's going to be like around half a second each. But now we can go into math and use some arithmetic operator like times or divided by, and rescale the values of this timing. So if we want it to be more different from the beginning, the 600, to the end around 500, we would like to multiply the values, so it will appear to change faster. So we'll amplify the change in the timing of the blinking by multiplying it. We amplify. So if we multiply by 2, if we say sensor times 2, which is a number, and the math is always, then we will be getting from 1 second, from 1.2 seconds to around 1 second of interval, right? And that's greater than it was from 6/10 to 5/10, right? We have multiplied by 2 the difference between the maximum and minimum also. And then if we want it to blink and chirp faster, we can multiply by a fractional number or divide by a number. We can say 0.5 and we will have 1/2. So it's going to be between 3/10 of a second and 2.5/10 of a second, something. So we can adjust with numbers here the values. Of course, as always when we are doing physical programming, there's a feedback between what we can change with the program and what we can change in the hardware. So changing the fixed resistor that goes in the voltage divider will also vary the numbers we're getting as input, as well as if we change the nature of the LDR for a different model with different values of varying resistance. But then just using some coefficient here to adjust the values of the sensor is an easy enough way to make it and fun enough to try. Okay, that's all. So, thank you.